You already know about the three primary trig ratios. You have sine theta, cos theta, and tan theta, and then also the ratios that go with them. So opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Now you're going to learn about three new trig ratios, which are the reciprocal ratios, and those are from 4.3. So the reciprocal of sine is 1 over sine, or in other words, cosecant. 1 over cos is going to be called secant. And then the reciprocal of tan, 1 over tan, is called cotangent. In other words, if sine theta is equal to opposite over hypotenuse, the flip of that, or the reciprocal, is hypotenuse over opposite. So same with cos, adjacent over hypotenuse. Secant is going to be the flip of that. So hypotenuse over adjacent. And lastly, cotangent will be adjacent over opposite. The types of questions we get are very similar to the same kind of questions that we have from primary trig ratios. So I'll give you an idea by looking at some of these examples. Number 1, given the following triangle, determine the 6 trigonometric ratios for angle A. So in other words, they're looking from angle A. That's where our eyeball is going to be. And then we're going to give all 3 primary and all 3 reciprocal trig ratios. So first of all, we have to use our eyeball to see which side the opposite side is. We also have to label the hypotenuse and then the adjacent. Now let's set up all of the 6 ratios. First you have your primaries, sine A, not theta because they had mentioned that we're looking from angle A, cos A, and tan A. So sine is opposite over hypotenuse, which is just 3 over 5. Cos is adjacent over hypotenuse, and that's 4 over 5. And then tan is opposite over adjacent, which is 3 over 4. The 3 reciprocals are cosecant A, secant A, and cotangent A. Since each of these guys is the flip of the other one, all I have to do is take the fraction and flip it upside down. So since sine A is 3 over 5, cosecant A is just going to be 5 over 3. Or you can think of it as the hypotenuse over the opposite. Okay, the next fraction was 4 over 5, so this one's going to be 5 over 4. And lastly, tan was 3 over 4, so cotangent is 4 over 3. Pretty simple. Number 2. Each angle is in the first quadrant. Determine the measure of each angle to the nearest degree. I'm not going to do all 3. I'm just going to show you one so that you know how to do the other ones on your own. So the first one says cosecant A, and I know that cosecant is the same as 1 over sine A. So if that's a reciprocal of sine, then sine A must be, since this is over 1, the flip of that. So 1 over 8. Okay? All I did was I just flipped these guys upside down. Then I'm just going to solve for A. And I do that by bringing sine to the other side, and we go like this. Angle A, so don't forget your angle symbol, is the inverse of sine with 1 over 8 beside it. Okay, and this is where we take out our calculators, and you're just going to go shift sine 1 divided by 8. And I got 7 if we round to the nearest degree. So approximation dot. Alright, and that's the exact same as you would do the other one. B is secant, so I know that that's cos, and I would just flip the 5 over 2 upside down. And then the last one is just tan, but then we would have to flip the 16 and the 5 upside down. Okay, the last question. Determine two angles between 0 degrees and 360 degrees that have a cosecant of -2. This is very similar to the question that we did in the previous tutorial, and that's where we needed to address the quadrants. Okay, first of all, I'm going to talk about this part right here. They're telling me that cosecant theta is -2. And since I know that cosecant theta is the reciprocal of sine, then sine theta must be a reciprocal of the -2, which is -1/2. So again, I just flip this upside down, but remember we always keep the negative on the top. Okay, so using the cast rule, C-A-S-T, I'm looking at sine theta and going, okay, well this is a negative fraction, which means that my triangles are not going to be in quadrant number 1 or quadrant number 2 because their sign should be positive in those quadrants. They're going to be here where sine is negative and also here. And I'm going to set up those triangles. So since this is opposite and this is the hypotenuse, in the T, the third quadrant, we're going to have opposite is -1 and the hypotenuse is 2. Then in the fourth quadrant, again, this is going to be -1 and this is going to be 2, my opposite and my hypotenuse. Because remember, your thetas are right here. Now this is starting to look like one of the, it kind of looks like one of the special triangles. Because doesn't the special triangle have a 1 and a 2? Meaning that even if I didn't know that it was a special triangle and I did Pythagorean theorem, I would find out that this would be √3. And this would also be √3. But then this one would be a negative because it's on the negative branch of the x-axis. Okay, so again, I'm starting to see this and it's starting to look like one of those special triangles, which means this angle is the 30 degrees. And this one is the 60. Okay, because it's opposite of their side lengths. And this one is 60. So what I would do in order to answer the question, the two angles, is I would start from standard position and then I would rotate all the way to the first terminal arm. Now that's going to be 180 plus 30 degrees, which is 210 degrees. My second angle is going to be starting at standard position. I'm going to rotate counterclockwise until I get to the next terminal arm. So that looks like it's 360, so everything. And then I'm going to subtract the 30 degrees, which is 330. Okay, so there are my two angles. Therefore, the two angles are 210 degrees and 330 degrees.